If you are into blockchain, you probably stumble upon the word DeFi. DeFi, or decentralized finance, is all about reinventing finance but on the blockchain. DeFi is growing fast and it's happening on the Ethereum blockchain. If you are a blockchain developer, you need to get on the DeFi train. That's where you will find most job opportunities. DeFi is really cool, but it's not easy to get started as a developer because you have to interact with the smart contracts of all these DeFi protocols, and it's not easy. What if you could use a REST API to interact with this DeFi project? You would send a simple HTTP request, that's it. That would be much easier. Well, in this video, we are going to build our own NodeJS API for decentralized finance by interfacing with the Compound protocol. And on top of it, it will show you a good example of what is backend blockchain development. If you don't know me, I'm Julian, and on my channel EatTheBlocks, I teach blockchain development and how to find your first blockchain job. The DeFi project we will cover is called Compound, one of the most popular DeFi projects. Compound is a lending protocol. It allows you to borrow or lend ERC20 token on the Ethereum blockchain. And you can also earn some interest by providing some liquidity. Loans are secured by collateral provided by borrowers, so you don't need any credit score. But on the other hand, you can only borrow if you already have some assets. There is much more to Compound than what I just said, but for our API, this explanation is enough. Next, let's see what's the architecture of our API. We will interface with Compound by building an API that runs on a Node.js server. We will be able to hit this API from any client. Could be from another server, a browser, or a mobile app. We will send HTTP request from the client to our API, then the API will forward this request to the smart contract of Compound on the blockchain by using a JavaScript library called Web3. Then the smart contract of Compound will send a response to the API and we'll finally be able to send a response to the client. Okay, enough talking, now we can start the coding, and first we need to make sure that you have installed all the tools necessary for our API. We're going to use Node.js for our API, so you need to install Node.js on your computer. If you don't have it, just go to the website of Node.js and install the LTS version, which is at v12 at the moment. You should also have access to a bash terminal. If you are on Linux or macOS, that's already the case, but if you are on Windows, you might want to have a look at Windows subsystem for Linux or a bash emulation like MinW64, which you can get by downloading Git for Windows. I'll let you make sure that you have everything installed, and after you can move on to the next section where we will create the HTTP server for our API. The basic component of our API is a HTTP server that listens to external requests and exposes different endpoints. We can create an HTTP server directly with Node.js, but that's easier to use a framework. Express is super popular for creating servers, but I don't like that we cannot use async await easily with Express, so we're going to use another framework called Koa. Koa is a lightweight alternative to Express that supports async await with a simple API. So next, go to your terminal and create a folder for the project. And then we're going to initiate an npm project with npm init-yes so that we don't have to answer any question. Okay, so now we have a package.json file, and we're going to install Koa as well as the router package of Koa. So after, we're going to create a new file, server.js. So first we require the Koa framework, and we instantiate an app instance. And next we're going to import the Koa router. We also have to instantiate a router instance. and we're going to define our first route, router.get. So here you specify the URL of the route. Then you have to give it a callback function, and the first argument of this callback is a context object where you'll be able to access details about the request that was received, and you'll also be able to start the response. So in order to answer, then you have to populate the body object inside context. And after that, you need to inject this router in the app. So for that, you do app use router.routes. Finally, you start the server with app.lesson, and you give it the port 3000. Okay. And then in package.json, we're going to create a command to start the server. So we're going to call this start. And after, in another terminal, you run npm start. And if you open another terminal, you should be able to test your server. So curl http localhost 3000. And I can see my hello world. Cool, this is working. And for the next step, we are going to connect to the Ethereum blockchain. There are different Ethereum networks, the real one that we call mainnet, and other ones that we call testnets. We are going to connect to the mainnet. To connect to mainnet, we need an Ethereum node synchronized to mainnet. We need more than 135 gigabytes of storage. It can take days to synchronize to mainnet, and it uses a lot of CPU. Clearly, that's not just a development tool that you can run in the background of your laptop. To save us the trouble of running our own Ethereum node connected to mainnet, we can use a service called Infura. Infura runs some Ethereum nodes connected to mainnet and let us access these nodes. We only need to create an Infura account and we'll get an API key. And they have a free tier which is enough to get started. So we are going to the website of Infura, we create an account, and inside your dashboard, you go to the Ethereum network and you create a new project. And you scroll down and you will see an endpoint for mainnet. It's better to keep this URL private, but it's not a disaster if you don't. The worst that people can do with this endpoint is just to use your quota with Infura. But nobody can do something really bad like forging somebody's signature and stealing your ether. So you copy the URL with HTTPS, you go back to your terminal, and we're going to create a file called .env. Let's open this file and we're going to paste our URL. Next, we're going to install an npm package called .env. This is a package to easily use secrets in your Node.js application. We're going to need that to read the Infura URL. It first reads a text file with your secrets and then populates environment variables with these values. By default, it reads .env text file, but we still need to tell it when to initialize itself. So open server.js and we're going to initialize .env like this. Now we can access the Infura URL in process.env.infura URL. Next, we are going to instantiate a connection to the blockchain with Web3. Web3 is a library to easily interact with smart contract on Ethereum. We will need it for interacting with a smart contract of Compound. So we're gonna create a new file called router.js. That's where we will define all of our endpoints, and that's where we will also instantiate Web3. So we go in this new file and we require Web3 and we instantiate it like this by using its constructor and using the Infura URL. And we're also going to move the route from server to the router file. So let's go back to server and let's cut this and paste this in router.js and we export this back to server.js. Now we're going to import the router, and so now we are going to restart the server and see if everything works fine. And yes, we can still see our hello world. So now the connection to the Ethereum blockchain work, and the next step is to create what we call Web3 contract instances to point to the smart contract of Compound. To create a Web3 contract instance, we need two things: the API or application binary interface. That's a JSON document that describes the interface of the smart contract, and the address of the smart contract. We can find these two things in the documentation of Compound. So you go to the website of Compounds, you go to the documentation inside the networks menu, and here you will find the address and the API for each smart contract for all the different networks where they deploy the contract. So we are interested in mainnet smart contract, and we're interested in CBAT and CDAI. In Compound, we have one smart contract per ERC20 token that we can borrow. CDAI and CBAT are the contracts for the DAI and BAT tokens respectively. But to make it even more simple for you, I already took the pain of copy-pasting the API and addresses inside the repo of EatTheBlocks. So you go to the repo of EatTheBlocks on GitHub, inside the folder of this tutorial, and you go inside config.json, and you copy everything. Then you go back to your terminal, and we're going to create a new file called config.json. Then we open this file and we paste everything. So now we have the address and the API. So the API for this token is the same. That's cToken API here. And I also put the API of ERC20 token because we're also going to need it later. So now we're going to the router file and we're going to create these two Web3 contract instances, one for CDAI and one for CBAT. So first we're going to import the config. Then we're going to define our Web3 contract instances in an object called cTokens. It's going to have two entries, one for CBAT and another one for CDAI. So we create a new Web3 instance. So we create a new Web3 contract instance with new web3.eth.contract with an uppercase C. And after we're going to pass the API and the address. So config.cToken API, config.cbat address, actually this is almost the same for CDAI, just here this is CDAI address instead of CBAT. And now we have our two Web3 contract instance. So we are ready to interact with the Compound protocol. And the next step is to create our first endpoint. For our first endpoint, we will return the token balance for a specific address in Compound. In Compound, if you want to lend a token, you're going to send your token to a cToken contract. For example, if you want to lend DAI, you are going to send your DAI to the CDAI contract. If you want to lend BAT tokens, you are going to send your BAT to the CBAT contract, etc. At any time, you can know what is your token balance in the cToken contract. This will not just give you the amount of tokens you initially sent, but it will also include the interest you earn. So let's start with this endpoint. So router.get, then we need to figure out what's the route here. So we're going to call this token balance, and it's going to have two parameters. First, the name of the cToken, so CDAI or CBAT, and then the address of the owner. And then we're going to give it an async callback. So we use the async keyword because inside we're going to use the wait keyword. Oh, by the way, we can get rid of that endpoint. So first we need to extract the correct Web3 contract instance. So let's define a cToken variable. And here we're gonna reference the parameter of the URL with ctx.params.cToken. So that's something that is given to you by the Koa framework. And it's possible that someone tried to call this endpoint with a cToken that we don't have. So we need to check for that. So if type of cToken is undefined, that means our endpoint wasn't called properly. Then we're gonna return a 400 HTTP response, which means this is an error coming from the client. And then in the body, we're gonna return a JSON document that says error cToken TTX params cToken. So here we use template literal to easily create our string. Does not exist, and we return because we don't want to continue in the callback. That was our error case. And after, we're going to call the smart contract of compound for our balance. So we're going to store the result in token balance, and this is an async operation, so we use the await keyword, and we reference the cToken variable dot method, and the function is balance of underlying, and we're going to pass what we got as a parameter in the URL, so ctx.params.address, and after that we need to execute the call method, and then we need to send a JSON response. So we specify what's the cToken, and then we specify the address, and finally the token balance. So here, when you want to assign a value with a variable who has the same name as the key, actually you don't need to do that in JavaScript. You can just use this notation and JavaScript is going to figure it out. So it's possible that there's going to be a problem with the blockchain when you try to read this value, and it might return an error. So we need to wrap this call in a try catch block. And if we have an error, then we're gonna log the error. So in production, you probably want to save this error in a log for further analysis. And then for the response, the status is 500. It means there was an error in the server, so that's not the client fault. And we can send a JSON that explains a little bit what happened. Error internal server error. Okay, so our endpoint is complete. So we're gonna restart the server and try out the endpoint. So we're gonna try this endpoint for the DAI token. That means we need to find an address in mainnet that has interacted with the CDAI contract of Compound. So I've already done the work for you, and so in the repo of EatTheBlocks, in the folder of this project here, I find this address that has some CDAI. So I'm gonna copy this URL, and in my terminal I'm going to try out this command. Yes, it works. So here I can see that there is a token balance. So keep in mind that this is scaled by 10 power 18, exactly like for Ether. So if you want to have the amount in DAI, you need to divide this by 10 power 18. Okay, so that's great. We created our first endpoint, and the next step is to create another endpoint to have the balance in cToken this time. So what is this cToken thing? So let's take the example of cDAI. So if you have some DAI and you want to lend your DAI to the Compound protocol, you send your DAI to the cDAI contract. So your DAI will be locked in the cDAI contract, and in exchange you will get some cDAI tokens. This cDAI token represents the DAI that you send to Compound, and at any time you can use this cDAI to redeem the DAI that you initially invested plus the interest you earn. So the balance in DAI is a different thing than the balance in cDAI. So we're going to build an endpoint for these cTokens. So back to our code, and we are going to duplicate the token balance endpoint because the new endpoint is very similar. So we're gonna call this cToken balance, and it takes the same parameters, the cToken and the address. So first we check if the cToken exists. So this is exactly the same, and here this is gonna be a little bit different. So here we're gonna get the cToken balance. We're still gonna call the cToken contract, but this time we're gonna call balance of. Actually, cTokens are ERC20 tokens, and they respect the interface of ERC20, so they have all the method of ERC20 token, like balance of, transfer, etc. So we get our cToken balance, and we respond by the name of the cToken, the address that we're checking the balance for, and here instead of token balance, it's just gonna be a cToken balance. And this is exactly the same. So as you can see, very few changes. So now let's make sure that it works. So let's restart the server, and below I'm going to check the cToken balance of the same address as before, but we need to change here token balance to cToken balance. And yes, it works. We can see some cToken balance here. So far, I've only shown you endpoints that allow to read value from Compound, but what's really interesting is when you can send transaction and actually modify the data of the blockchain. And that's what I'm going to show you in the next part. In this part, we're going to create an endpoint to mint new cTokens. For example, in the case of DAI, if you want to invest your DAI in the Compound system, when you send your DAI to the cDAI contract, this is called minting cDAI, because in exchange you're going to get some cDAI. Because this is an Ethereum transaction, we need to sign it with our private key. So for that, we need to create an address. And for that, I'm going to a website called Vanity ETH that allow you to generate an address very easily. So of course I do it like this for the demo, but when you create your own system for production, of course you want to use something a little bit more secure. So I click on generate, click on reveal the private key, go back to my code editor, and I'm going to open .env where I store my secret. And below the infra URL, I'm going to create another secret private key. Okay, save this, and back to router.js, and I go to the very top, and I'm going to add my private key to web3. So web3.eth.accounts.wallet.add, and our private key will be in process.env.private key. And we also want to extract the address from this private key because we're going to need it to sign our transaction. We're going to call this admin address. It's going to be web3.eth.accounts.wallet, and here we take the first entry. Alright, so now we're all set to create our endpoint. So I'm going to copy the first endpoint. It's going to be our template. I'm going to go to the bottom of our code. Yeah, let's paste this. Let's paste this. So this time, this is not going to be a get route, but this is going to be a post route, because with HTTP verb, you use get only when you read data and post when you want to modify data. And we're going to call this mint, and we're going to keep the cToken param, but instead of the address here, this is going to be an amount param. So that's how much cToken we want to create. Then this check here is still the same. And after, we are going to get the address of the ERC20 token. So let's store this in token address. And for that, we can ask our cToken smart contract, and there is a method called underlying. And use the call method. Oops, I forgot dot methods here. And after, we want to create a Web3 contract instance that can point to this ERC20 token. So we pass first the API of ERC20 token that we have in the config object. And for the address, well, we just got it from cToken. And now we need to approve the cToken to spend our token. So for that, we use the approve method, and we're going to pass it two arguments. First, the address that we want to approve. So that's going to be in cToken option address. And for the amount, we got it as a parameter to the context. And we send this with the send method. And for the sending address, that's going to be the admin address. So now we've done all the prep work, and we can finally send our token to the cToken contract. So here, let's remove this, and this time we're going to call mint. And we're going to pass it the amount parameter. And this is not a call, but this is send, because we send a transaction this time. And the sending address is again admin address. So we're going to return the name of the cToken, then the address that we minted cToken for. So that's admin address. And finally, the amount that was minted. So this is what we got in the param. And for the catch block, this is unchanged. Okay, so let me save this and restart the server. Make sure that we don't have any error. Okay, so you'll notice that there is a huge security hole in this endpoint, because anybody can call this endpoint and spend all the DAI that you have in the admin address and send everything to Compound. So it doesn't mean that you lost your DAI. You can always get them back because you still own the CDAI, but you might not want to invest everything in Compound. So you probably need to implement some sort of access control system, or maybe that you manage the private keys on behalf of users, and instead of using the admin address to execute the mint function, then you use the private key of users. But this is a bit outside the scope of this tutorial. So that's really cool. We know how to invest our token in Compounds, but now we want to do the opposite operation, which is to redeem our cToken for the original tokens. And that's what we're going to do in the next endpoint. So we're going to create a new endpoint for the redeem operation, which is the contrary of minting. So you send your cToken to Compound, and in exchange, it's going to send you back the underlying token. So if, for example, you have some CDAI and you redeem with CDAI, then you're going to get back your DAI. So I'm going to copy paste the endpoint for minting, because this is going to be a little bit similar but more simple. So we're going to call this redeem, and it accepts the same parameters, cToken and amount. So we first check if the cToken exists. Then we don't need to approve anything here. And then in the try catch block, this time we're going to redeem. and we pass the amount that we want to redeem. So this amount is different than the amount of underlying that we used in the mint endpoint. This is the amount of cToken that we want to redeem. So for example, if you redeem 10 cToken, it doesn't mean you're going to get back 10 DAI. It depends on the exchange rate between DAI and cDAI. And it's also important to understand that you're not going to get just the DAI that you initially invested, but you're also going to get the interest you earned for lending your DAI. And in the response, this is not amount mint, but amount redeemed. Okay, so let's restart the API, no errors. So this is working. Great, so now we have 4 endpoints, 2 for reading and 2 for sending transactions. And in the next part, we are going to deploy our API to Heroku. Heroku is a platform to very easily deploy your applications. You can deploy APIs, React applications. This is much more lightweight and simple than something like AWS, and for simple applications this is enough. They have a free tier, however it gets expensive quite quickly. But for our tutorial it will be perfect. So back in my code editor, I'm gonna go in package.json and I need to add a configuration for Heroku. So I need to specify what's the version of Node.js that I use. And so you specify this in the engines property. And we're going to specify node 12.x. Okay, and by default, Heroku is going to start the server with the start script. So we have one, that's perfect. However, we need to do a small modification in server.js because we need to bind to the port that is specified by Heroku in process.env.port. And to also make it work without local development, we're going to put a all condition. So if we deploy to Heroku, this is going to be defined, and if we just run this locally, this is going to be undefined. So in this case, by default, we're going to use port 3000. Next, I go back to the command line and I'm going to initialize a Git repo because this is the way you deploy it to Heroku. Then we're going to create a git ignore file. We're going to ignore a couple of stuff. So node module, so that's a dependency of npm. We don't want to commit this to git. We also don't want to commit our secret. Oops, here there's no s. Let's exit this. And if you do git status, then we don't see any ignore file, so that's okay. So let's add everything. We call this initial commit. And after, we are going to log in to Heroku. So before, you need to create an Heroku account and install the Heroku CLI, so you can install it very easily on macOS with Brew. Or Linux, we have another method with Snap, and for Windows they have an installer. So back in my terminal, I'm gonna do Heroku logging. Then you're gonna see this screen in your browser. So after, I'm gonna create a new application with Heroku create. Oh damn, I have to delete some of my app because I'm using the free tier. All right, I've done it. So now I try again. And yes, it works. Next, we need to set environment variables for our secret because we did not commit our secret file.env. So let me open the env file, and first I'm gonna copy infra URL. And I can create an environment variable with Heroku config set, then the name of the environment variables, the infra URL, then equal, then the value that you want to assign. Okay, and I'm going to do the same thing for the private key. So same command, Heroku config set, but this time we're going to call this private key. Okay, so finally we are ready to push our application to Heroku with git push Heroku master. and I'm gonna do curl, and then I go to the repo of EatTheBlocks, and I'm gonna copy the path of the first endpoint here. Damn it, we have an error. Oh, and it seems like I forgot to put web3 in package.json. So let's do this. Okay, so now I should see this in package.json dependency. Okay, so I'm gonna commit this change, add web3. And by the way, if you wonder how comes I figured out what was the error, it's because in the dashboard of Heroku, if you click on more, you can view the log. And so here I scroll through the log and then I found the error message. Okay, so I'm going to push everything to Heroku again and try our endpoint one last time. Okay, so let's try the endpoint. Yeah, this time it works. I hope you are super happy with what we built. It's pretty cool, but you shouldn't stop here. We can make our API even better. Currently, we don't cover all the function of the smart contract of Compound. You could add other endpoint for the missing functions. You could also add endpoint for other DeFi protocols like Uniswap or MakerDAO. And to do that, you need to first have a good understanding of these DeFi protocols. I actually have a full series on DeFi programming where I explain the main DeFi protocols like Uniswap, MakerDAO, and more. And if you want to continue your journey in DeFi as a blockchain developer, go watch this series. I'll see you there.